shoe time. These, yes, they're sparkly and they're pink. And
I feel like if I were wandering downtown at like some big city like New York late at night, I want those shoes on just in case I had to kick somebody.
I would think so.
Yeah. So today we're looking at 1.4 representing categorical data with graphs. We already looked at this just a little bit in the last video, so we're going to keep on that thread, and we're going to jump straight in. Sometimes I'm going to skip over the essential knowledge, so come back at this point in the video, at the end of the video, make sure you feel A-okay, and let's jump straight into talking about the different types of graphs. Yep. So what grade do you think you first start talking about pie charts, Mr. Bobby?
Oh, I don't know. That's elementary sometime, like, I don't know, probably third or fourth grade. They make, well, maybe when they start talking about angles, maybe a little closer to middle school, but still, it's an elementary thing, you know.
It's pretty young. So I was telling Mr. Bobby before we started this that I wouldn't ever expect you guys to make a pie chart by hand, but he's right. Like, you need to at least be able to like draw the circle and understand what half is and understand what a quarter is and things like that. But really what you want to look at when you're looking at a pie chart is, because this is parts to a whole, you want to look for anything that's like a large portion of the circle or a very tiny portion of the circle. So this particular circle was, they did a survey on the different types of streaming that people preferred. And I think you can see here that a really large portion of the people in this survey said Netflix.
Although I'm liking the Disney Plus. I'm all about the Disney Plus thing now.
And then a very small portion of people like the HBO Go, which HBO Go, I think, actually just changed their names like HBO something else.
HBO Max or something. Way to be timely there, Miss Young.
Anyway, so that's the circle graph or the pie chart. And then we talk about a bar graph. So this particular graph that I found is a distribution of people who prefer live TV versus, I'm trying to remember now, I looked up what all these meant and now I can't remember, a connected device like a PlayStation or something like that. I think that STV VOD was the inputs on the television, like if you have a smart TV, how you can go to an app inside the television. Okay, it doesn't matter anyways. The point being here that because the one that I found most interesting is look at that live TV, which we have Direct TV now, which is our live TV. And I was trying, after I saw this graph, I was like, how often do I watch live TV off of our Direct TV? Never. I never do. But if you look at the bar charts, you can see here that you've got categories within each age range. So 13 to 17-year-olds, only 2% of them prefer live TV. But if you jump all the way over here to 55 plus, you know, almost 60% of them prefer live TV. Why do you think that is, Mr. Bobby?
Because that's what I grew up on. Thanks for making me feel old, dude.
So you're not in that age range.
No, but I watch live TV from time to time.
I hardly ever watch live TV. Anyways, this is a bar graph, and it's a little more complicated than like your traditional just one for each category, meaning like I could look at more than one variable at a time.
It allows you to do a comparison between two different variables. That's the gist of this particular graph.
So, okay. This is called a segmented bar graph. So this is where we're kind of stepping up our bar graph game. So this is just a bar graph. Even if it's got multiple bars, it's just called a bar graph. But then when we start stacking those bars, stacking those bars on top of each other, then you're talking about a segmented bar graph. And look at another thing that changes on that y-axis. That y-axis is now relative frequency. It could be frequency, but way more often it's relative frequency. So, Mr. Robbie, why do you think that we prefer to read off of a segmented bar graph?
Well, I like this one because it allows me to compare the two groups between the students and the teachers and what they prefer. I can see whatever that blue category is, it's way more popular with the students.
Yeah,
And
AP
the orange
statistics.
category is more popular with the teachers than with the students.
Pre-calculus is orange.
Yeah, I can see the categories, but I can, even without reading the labels, I can tell
Yeah.
they're not the same. Okay,
Yeah.
before I even get to the label, I can tell there's some difference between students and teachers,
Yeah.
and that's the ease of this.
Yeah.
Uh,
And as usual with any type of categorical graph, the thing that you're looking for is like, is there a category that stands out? And that really means like look for something that's bigger than the rest or smaller than the rest, right? Look for something that stands out. Or maybe do what?
One of these things is not like the other.
Right. Or they're exactly the same, because that's actually kind of interesting too. And we're going to talk about what that means later on. This is called a mosaic tile plot. And it is a new graph. You know how like you think math never changes and like, you know, statistics is such a new math that it is constantly evolving. And so a mosaic tile plot is our newest evolution in graphs. And what happens is it looks a lot like that stacked bar graph. So let me go back. Stacked bar graph.
The same heights there, but I see, let me ask you a question. In your school, or in any school,
You hope.
in most schools, yeah, let me just say, are there more teachers or are there more students?
I would really guarantee that there would be more students.
Almost every school I've ever experienced, there's way more students. Hey guys, you got the power. There's more of you than there are of us. You can take over the world. Okay. Well, they'll be paid for. But the width of the category determined is relative to how many are in that population or in that group. So there's more students. The student category is wider than the teachers.
So to be clear here, when we talked about bar graphs, we told you in a bar graph that the bars had to be the exact same width. And that's true whether we're talking about the standard bar graph, the segmented bar graph, either kind of bar graph, those widths better be the same. Otherwise, you get a misconstrued idea of what's happening. But the mosaic, if the bars are the same, that means those populations are the same. They're the same number of students as teachers, right? So with the mosaic, the width of the bars will depend on how many people you answered the questions. Also, it's all squished together in one beautiful graph. So there's no separation of bars with your mosaic tile plot.
And it not only gives me a comparison between the two, but it also gives me a hint about the total that are in each category. So I know initially maybe didn't seem like it, but of the entire population of the school, a lot of people like AP Stats, which is a lie because everybody loves calculus. Or college algebra. You didn't even put college algebra. It would have been all college algebra.
That's true. That's true. It's because college algebra is so easy. Okay, so let's make up some data. Here's what I've got. I've got males and females, and I should have added an other here under gender, and I didn't. So that's like, if I make up data again, that's something that I will fix. And then you've got all these different superpowers. Okay, so we've got a two-way frequency table with superpowers and genders. Yeah. So how many variables do you see, Mr. Bobby?
Now, some kids might think that there are 5 superpowers and 2 genders listed, so that might be 7, but there's really only 2.
That's
right. Superpower across the top and the gender down the side.
Remember that a variable, guys, is what changes in the problem. So female and male, those aren't two, like, well, anyway, so the female male would be the thing that changes. Female male would be the thing that changes, the variable would be gender. To fly, freeze time, invisibility, superpower, telepathy, those are changing from one to the other, so the variable would be superpower. So 2 variables. And Mr. Bobby already told you the 2 variables are gender and superpower. What type of categories are those? How about that? What type of variables are those?
Those are categories.
Yeah, they are. So we have two variables, gender and superpower. Both of them are categorical. All right. So a summary statistics. So here's a graph where I'm showing you a breakdown of percentages, and I hope you remember. I'm sorry?
The frequency table.
Yes, that it's called a relative frequency table, and that this green box that I'm showing you here, I gave you a name for it, and those were your conditional relative frequencies. What did I make this graph conditional on, Mr. Bobby? Do you know?
Well, wait a second. It looks like
On
condition on the superpower.
on the superpower, yeah.
I didn't read it a little closer.
Yep.
I'm still laughing in my head.
Yeah, thanks. Okay, so if I were to take these conditional relative frequencies and make a graph, then it might look something like this. Now, I've shown you 3 graphs that all represent the same data. The first graph is just a normal old bar graph. So you can see from this that the males and females, the males are dark blue and the females are light blue, about the same percent share the desire to fly. And you can go through your bar graph and kind of compare that way. Or you can look at that stacked bar graph. Which one do you prefer, Mr. Bobby, the stacked or the original?
I'm really liking the stacked a lot more the more I use it, more and more I use it. But it does take a little getting used to. But you can really tell if it's a 50-50 split, like the to fly column, it would be in the middle. But if one of those stacks is way bigger or the other, that pretty much quickly tells you that is preferred by the one or the other.
Right. So I find myself when I'm having to look at the original one, the one that we grew up on, where they're just 2 bars next to each other, I have to start from the left and remember that it goes dark blue, light blue, dark blue, light blue, so that I'm comparing the right 2 bars. If I look too quickly, I might compare the wrong 2 bars. I might compare this light blue and this dark blue. Mm-hmm. So I love the stacked. I love the change into the stacked because there's no question about like what bar goes with what, because it's just one bar where you're looking at that relative frequency.
It will take, it might take a little mindset shift for you, but the more you look at it, the more you'll like it.
Yeah. And then the last one here is our mosaic. The nice thing about the mosaic is which proportion of superpowers do people prefer the most? Or which superpower do people prefer the most? That's what I'm asking you.
Well, it looks like there's...
So you're looking at area.
Yeah, we're looking at area.
Which one has the largest area?
The dark blue has the more, but that's male. So there's more males. I'm having a hard time reading your little titles across the bottom too. So that's something
to fly, freeze time, invisibility, super strength, telepathy. Yeah. So obviously that to fly rectangle is the largest rectangle that we see here. So the nice thing about that mosaic is we can immediately see there's more boys than girls, and flying is the overall most preferred. Right.
Gotcha now. I got
you. Yep. Whereas like to freeze time is like that skinny little rectangle. Not a lot of people chose that. And so that's something that we can get from the mosaic that we can't get from the other ones. We just, you just can't get that same idea of overall population idea. Okay, now I'm going to flip the script a little bit. Right now, all of the x-axes have the superpower on them, but I didn't have to do it that way. So then I said, okay, what happens if I put gender on the x-axis? And does it matter? So let's take a look at this gender one. We won't spend as much time kind of going through the graphs, but wow, I dislike the traditional bar graph when I've got 5 bars that I have to compare. I don't like that at all. Yeah. So I move on to the female male, And what do you think? You like the stack?
I like the stack because I can quickly see and compare the green is much larger for the females than for the males. So I'd look and say, oh, green is what, telepathy?
Mm-hmm.
That would be a really smart power for someone to pick. And
yeah,
you know,
of course the girls picked it.
Yeah, girls, because the boys pick something stupid like super strength. So yeah, ooh, I can lift a box. Okay, they make forklifts for that.
Yeah, and then we move on to the mosaic, and again, you're looking at size and all that stuff. I myself am still getting used to the mosaic. I prefer the stacked of all the graphs. So, you like this?
I like it. And
okay. So here's my question. Do you think there is a variable that would best explain or predict the other variable? So remember, we have two variables. One is gender and one is superpowers. So do we think one will explain or predict the other?
Well, I think I kind of already alluded to that, where I was said that when the girls might pick a smart superpower and boys might pick a stupid one. So I'm thinking that gender might influence the, well, sorry guys, we do stupid things, all right?
So I'm in agreement. I do think gender predicts superpower. But guys, that doesn't stats is a weird animal. So I'm gonna say gender probably predicts superpower in this case. Now, in algebra, we have independent variables and dependent variables. In statistics, we have explanatory variables and response variables. They're the same. Okay? Same exact concept.
Now, just because we both think that doesn't mean we're right. Okay? Right. Don't, we'll see, the whole course is us coming up with a theory and then ultimately trying to see if we can find evidence to support our theory.
Right. So if we're thinking about the scientific method, we're in the ask a question phase, right? We're in the ask a question phase. So at this point where we think this might be true, now we might ask the question, does gender predict superpower? And then we would begin a series of steps that would allow us to say yes or no at the end. Okay.
With a certain level of certainty, but not, we can never prove such a thing, but that's
we'll get there. That's a whole nother thing. Okay, so look at the graphs where I've left gender on the x-axis. What do you think here? Is there an association between gender and type of superpower?
Well, I mean, there are differences there, so they're not. I can tell. Like I said earlier, I guess I was smarter than I thought I was.
You were.
Was that more females picked telepathy than males, and vice versa with the super strength. And if I were comparing, I could see the ability to fly is somewhat similar. Okay.
So, I might say that knowing your gender will change the percent of the superpower chosen. So if we say yes because the percentage changes, then what if there's no association? What would these graphs look like?
Well, I wouldn't be able to tell much of a difference, or they would be pretty close to one another.
Right.
So I guess would they be flat, or would they be copies of each other? I don't know.
They would be copies. Yeah, they would look the same. So that's it. You're going to go ahead and jump onto Khan. Once you finish all the Khan Academies from 1.3 and 1.4, review the video one more time and go ahead and try the quiz on 1.3 and 1.4. I hope you guys found this super helpful. And remember, we are available in the evenings if you need us. Shall we tell them to sparkle on, Mr. Bobby?
That was the other day's shoes. Oh. They got a spike on,
That's frightening. I don't know that I want to tell people to spike on.
Okay, well, maybe not. How about we say bye, y'all?
Bye, you guys.